So who we are? You may not recognize Reza because of his new hairstyle, which I couldn't when I first saw him this year. So you want to
introduce? Yes, my name is Reza Rahman. I'm a Java evangelist at Oracle Corporation. Up there is my Twitter handle and email address, not up there just for giggles. You know, if you have any questions on any of this or Java EE generally, please feel free to reach out to me. And I am the track lead for this track that you're on at the moment. So if you have any comments or suggestions whatsoever on that track, I'll be happy to take those as well.
And this is Murat. I work at Intel as a mobile developer. So the talk which we'll have today has nothing to do with my daily job, but I've been interested with Java EE since from the early days, and I happen to write a book with my co-author, Alex there. Again, I didn't want to have him on stage because of his hairstyle. we need some long hair guys. I'm losing my hair, so that's why I wanted Reza, but that was a surprise. So any of you have the book? Okay. If you don't, we have a discount code, and if you ask questions, you can win one. So,
yeah, so good incentive to ask questions. In fact, for this particular session, the way we'll run it is to make it more discussion-oriented. So don't hold up until the very end to ask questions. Ask us questions in the moment, and if it's a really good questions, you get to win a free book. And it's not a cheap book either. It's like $50 or something, isn't it?
Yeah.
So $50 question.
Alex brought them with him, so you can just ask him about the REST 47 or something like that. So what are design patterns? How they just emerged? So actually, when you go back in history, you just realize that everything started with object-oriented programming. And when you read about design patterns, you just kind of a feeling that Dijkstra might be right, which I don't really agree. Then Gang of Four appeared, and they published a book which introduced the list of design patterns. And after that, at Java EE World in Java 1 2000, there was a talk about prototyping patterns for Java EE platform, which became a very successful session and become a book, which has been a standard for a long time. And after the introduction of Java EE 5, most of the Gang of Four design patterns, and actually more, have already been implemented in Java EE. So they have the out-of-box implementations. You don't really need to do anything. So if you just, this is the main summary of the talk. Java EE has almost all the patterns, so you can just go and have some beer. But if you still, instead of listening us, let's move to Singleton.
Okay, so I just want to clarify the previous point that that Murat was talking about. So essentially, Gang of Four is a famous book. I think at least some of you have at least heard of Gang of Four. Gang of Four has a bunch of different patterns. Okay, not all of which are actually that common in enterprise applications. However, the ones that are actually common to enterprise applications, those instead of having you having to implement those patterns, it's actually baked in as part of the APIs of the platform itself. Okay, not all of them, but certainly the ones that you would use in the 80 to 90% use case. Okay, so Singleton is a pretty good example. So let's start there. Essentially, the Singleton design pattern, if you read the Gang of Four books, is really about having a single instance in the JVM of an object. Okay. And why do you need this? Well, the Gang of Four motivation was essentially heavyweight objects, objects that you wouldn't want to create, and because they're expensive to have around, and that's why you would have this Singleton pattern, forcibly if you will, force object orientation into forgetting about objects and really thinking about making a one-to-one relationship between a class and an object instance. And if you've read any further in the Gang of Four patterns, implementing the singleton pattern is quite non-trivial. You have to start with some pretty unnatural constructs, like private constructors and thread synchronization and the like. Okay. So, and of course, and in the end, you still didn't get thread safety. Whatever object that you were producing in the end, your singleton object, still needed to think about thread safety because, after all, it's just a single instance being shared across the JVM across multiple threads. So, what we've done in Java EE is to simply introduce this concept of a singleton. Okay, so if you want an object to be a singleton, well, you don't have to go through all of the mechanical details of all of those nasty-looking Gang of Four recipe code to do all of that. What you simply do is you stick this @singleton annotation on a class definition, and this effectively makes it a singleton. Okay, so no more crazy private constructors or thread safety concerns or anything like that at all. In fact, this object by default is read locked. Okay, so all access to it is serialized. All right, so you don't have to worry about thread safety at all. So let's get to, I guess, the expensive construction part. That's remember, one of the principal motivators of why you would want to have a singleton in the first place. It's expensive to create.
Can I ask a question?
Yes, absolutely.
Why do you prefer the server just an enum with a single value? Why is this preferable to an enum with a single value that has the same singleton effect?
Please ask your question a bit differently.
Okay. Everybody knows singleton is like the most famous design patterns. And there's lots of ways of doing it, and you're right, the way Gang of Four described it was ugly. One way of doing it in Java, and I'm not an expert, so I'm just my understanding, is you could create an enum and have a single value in it and have all of your methods on that. Would that have the same effect? Some advantage to what you got here?
There's a bunch of advantages to this. So first of all, look at the syntax. It's far more natural.
Sure.
It's simply a Java class. Like any other Java class, all you're doing here is sticking a bit of declarative information. Think of this as the application server as a JVM on steroids, and all you're telling the JVM is, please make sure this thing is a singleton, right? And you don't have any other besides that. Your code artifact looks very much like a natural coding paradigm, as opposed to doing something quite artificial. So beyond that, there's other benefits as well. The other one being that this is entirely thread safe. Okay, out of the box, you don't have to worry about thread safety concerns at all. Whatever access you have to this bean is going to be automatically thread safe for you. Okay, there's no way you can run into a threading contention for a singleton object. Okay, all right. So going back to my point. Okay, so original motivation for the Gang of Four singleton. Expensive objects that are expensive to create. Okay, so how do you do that in this world? Well, what you do is you can do a couple of things. You can certainly create a classical constructor. There's no problem doing that. Okay, and just do whatever you need to do in terms of object setup, initial object setup in your constructor. However, there's an even more elegant way to do that. That hooks into the instantiation of the object itself in the Java EE environment, and that's this other callback called post-construct. So you simply have a method where you do your object setup, and you simply stick the post-construct method on it. And the nice benefit of this, especially as compared to handwriting a singleton pattern, is that the lazy initialization part will actually be done for you. Okay, this post-construct method will be invoked only on the first access, okay, of the singleton object. Similarly, you can actually force eager loading as well. Okay, so let's assume you have a case where you do want this object to be available right out of the box when the application starts, and you can very easily do that by just adding the @startup annotation. Okay, and this will make sure that it is eagerly initialized as opposed to lazily initialized. Something, by the way, that wouldn't be possible, okay, to do in a classical singleton pattern. Yes, sir. The scope is, technically speaking, class loader, yes. Yeah, in a Java EE application, it would be the current class loader. Mm-hmm.
Is this Java 7?
This would be Java EE 6 onward. Okay? Yes, sir.
So the obtaining of the reference is thread safe, but if one thread
Not at all. So this is how it works. So this is how you get a reference to a singleton in a Java EE environment. You actually simply say @inject singleton bean, okay? And what you will be given here is actually a reference to the underlying instance, okay? So this is in fact a proxy under the hood. So whoever is accessing this at any point in time is actually accessing that single instance available in the JVM somewhere. And that access is granted only on a thread-safe basis. So if you have two threads accessing the same instance at the same time, they will be forced into serialized access. Even calling methods in the instance. Most certainly calling methods in the instance, yes. That would be the whole point. Okay. All right. So what are the benefits of some of this? Of course, expensive objects, the thing that we talked about, the original Gang of 4 motivation, that's still valid. The other nice thing the nice access nice use case that this singleton pattern meets in a Java EE environment is things like caching and shared data. So if you have anything that you want accessible throughout the JVM, this is a nice place to stick that bit of information. What are the bads? Well, overuse, just like anything else, if you overuse it, it'll be a problem. You don't want to have too many singletons and too many heavyweight singletons. It'll eat up your memory and it will never be released, essentially, because it's a single instance. And similarly, you have to be careful about when you want this data to be loaded, right? So if you lazy load everything, that means that you'll pay a cost on first access. Okay, the person that accesses it first will pay a cost, and the opposite problem. If you eager load everything, you'll pay a cost in terms of memory. So it's a question of what do you trade off, CPU versus memory. Okay, at runtime. The ugly, these days it is considered an anti-pattern. In fact, in most Java EE applications, you generally will not use singletons except for some niche cases. Okay, there are some other frameworks out there that will remain nameless that use singletons quite heavily. The big problems with these are issues like thread safety concerns and the like. Okay, so in Java EE, we do recognize it as an anti-pattern. You should really only be using it when you need it. By default, the smartest thing to actually do is use something called stateless session beans rather than singleton session beans. Okay, moving on, and Murat takes over for Abstract Factory.
So factories. As listed in Gang of 4, they are creational patterns which are used to encapsulate the creation of the objects. So the main motivation is not to create objects with new, instead just ask the factory, and the factory just creates the objects for you and gives you the instance you want. And it's usually very good because it will encapsulate all the parts which are subject to change, so you don't need to change all your code and classes when a part of the creation system has changed. So moving to Java EE, if we just change an ordinary bean into a factory, we just add the producer's annotation, which turns this method into a string factory. So whenever a string object is injected to a resource, this method will just get in action and produces the string, and the string produced by this method will be injected into the target.
So a quick note here, you can actually assign a scope to the object being produced as well. So by default, this is something called the dependent scoped, which is essentially the default scope. It's equivalent to new, which means this producer will be invoked every time you do an injection. However, you can assign any scope to this. So you just add the scope type right after the producer's annotation. So if you wanted, for example, something that is application scoped, you would simply say producer's application scoped. Okay, and that would mean that it's instantiated only once, okay, per the entire application.
And I don't know why these empty slides are showing up, but so what about the ambiguity? If we have two different instances of the same type of object, then we end up with ambiguity of the type system. So in that case, we use the qualifiers to solve the ambiguity. As you see here, we can just use the named annotation and just give some names to the factories. So each client will just need to annotate which factory it's really targeting and listening. So it's a very easy way to solve the ambiguity. So the good part, it's very, very easy to implement. You just add the producer's annotation, and it just creates the magic. No boilerplate code, and everything just works magically. The bad part, named annotation is not type safe, so same type of objects can be wrapped or annotated with qualifiers. And the ugly part is it may introduce some level of understanding if someone is new to your project, because the execution flow just works magically. Some part of your code is producing some objects, and they're magically injected into some other parts, which is not really the way you just follow the code and read everything. But again, it's not a huge deal when you just check the pros, I guess.
Yep. And you can also, the IDEs can also help you out. For example, NetBeans has a nice little wizard to say, okay, for this produced object that's being injected, please find the corresponding producer.
And there's no problem with debugging. Debugging also works magically.
Okay, facade. This is an interesting one in some sense, because it's debatable whether it actually deserves a separate name or not. So what is facade in fact about? The simple definition, if you read it, it's on the slide. It says hides the complex logic and provides an interface to the clients. Well, sounds awfully familiar, right? This is nothing much more than the core part of essentially abstraction, right? One of the core principles of object orientation. So what is special about this, and why precisely does it deserve it in its own name and sort of its own place in the catalog of design patterns? Well, it's not merely about creating abstractions. It is about creating a specific type of abstraction. In an enterprise system, what you'll find is when you're designing the system, you'll wind up with a layer called the application layer. It's a layer that sort of describes at a high level what is it that particular part of your application or subsystem does. Okay, think of this as high-level use cases, the types of use cases that a business analyst may describe. Right, do this, do the other thing, and so on. So perhaps perform an order, or get a list of products that match this particular search criteria. These are your high-level APIs describing your middle tier of your application. Okay, that is really what you are doing using as a facade. And the facade is simply an abstraction to describe those high-level use cases to any users above that layer. Okay, so talk about whether it's the GUI layer or perhaps a remote service invocation. They're talking to you in very simplistic terms and telling you, please do this, and you figure out how you do it. Okay, so the underlying code for that would be non-trivial and fairly complex. How do you do this in a classical gang of four fashion? Really, not very difficult at all. Generally, these are assumed to be stateless objects, and you simply write a thing that looks like something service. You would typically name them that way, or something facade. And then you simply create essentially atomic methods, okay, methods that do a single thing. That's generally how it's implemented in gang of four. So, question is, what precisely does Java EE give you in this case? Well, Java EE has a specialized annotation, and the annotation that I talked about before when I was talking about singletons and that is the stateless annotation. Okay, so it is essentially a marker to denote the fact that this is a facade. Okay, it is essentially intended to be stateless. It's intended to describe the atomic operations at the service level. But beyond that, the stateless annotation actually will do some other useful things that pertain to the purpose or the real purpose of a facade as well. So one of the biggest ones is this facade also is entirely thread safe. Okay, so however you access this object, it will be thread safe, but it is not a singleton. Okay, so it is made thread safe despite not being a singleton. Okay, it's beyond the scope of this talk as to how that occurs, but again, it's a bit of container magic, but essentially you can assume this is a stateless and a thread safe object. You can never run into thread safety problems in the business logic access. It is also by default transactional, which is useful for that tier of your application. Generally, you would want those high-level use cases to be transactional. Also, it includes things like monitoring, management, as well as pooling. More importantly, defining upper threshold pool sizes for these services. And again, very, very useful in creating sort of high-level scalable applications, high-level scalable API layers in your enterprise applications. Okay. How do you access it? Again, the answer is pretty much always the same. Okay, you stick an end at inject annotation, and wherever you want this thing injected, and the container will do the rest of the work for you. You don't have to do really anything at all. Okay. Yes, sir. Mm-hmm. Okay, so this has to do with the fact that it is stateless in terms of what the API expectations are. However, the stateless under the hood, the implementation may be using things that are in fact stateful. For example, you could have an entity manager instance, okay, that connects up to a database. So the purpose of the thread safety is to shield the implementation from any thread safety concerns. Okay, so it's stateless in this particular sense is just a marker to tell the client that this can be accessed in a stateful manner. This object is not expected to hold state. However, you could be holding state anyway, okay, because it's useful to do so in the implementation. Why does it need to be pooled? Well, very simply, when this object this is essentially a backbone of your application. Okay, let's assume that you have let's say a create order method in there, and let's assume that you get a sudden burst of orders, and suddenly you have 10,000 orders to process concurrently. Okay, so because of the fact that this object, the stateless object has an implicit upper bound, really what will happen is you won't run into a thread starvation situation. Okay, it will only be processed with the upper bound of the thread pool, which is typically something like 10 or 15 or 100 threads. Okay, somebody else had a question. Yes, sir. Actually, that's a good question. So let's wait. Maybe you're a candidate for winning the book. Okay, but yeah, that ups the stakes for the rest of you, by the way. Okay. Not much at all. I would say in the order of milliseconds. Yes, sir.
It used to be that we applied stateless and stateful just to EJBs. Is that still the case, or can you have a stateful and stateless object outside of EJBs in our
You most certainly can. So yes. So the answer is yes. Stateless and statefulness generally is the domain of EJBs as to with regards to your service tier. But there's other ways of declaratively managing stateful situations in Java EE as well. So these days there's a whole bunch of CDI annotations, so request scoped and application scoped and session scoped and the like. So those would be implicit state handling as well, state handling situations. Yes, sir. I can barely hear you. I'm sorry. Somebody's gonna have to either relay that question or you're gonna have to speak up. Can somebody relay that question, please? Somebody in the middle? You could, yeah, you can have an interface. You're not required to have an interface. So stateless and stateful session beans do not require an interface anymore. You can opt to use an interface if you so wish. Me personally, I tend to take a KISS approach. Okay, keep it simple, stupid. If it's unlikely that I need that high level of decoupling through an interface, I generally tend not to use one. In circumstances where it is clear that having an interface is helpful, most cases I'll add an interface later. Okay, but either way, EJB doesn't care. You can have an interface. You can skip the interface, whichever way. Either way, it works. Okay. Any other questions? No, very good. Okay, moving forward. Okay, again, very simple, very robust. It gives you a whole bunch of services. You can add more services on top of it because it's an EJB. You can add scheduling. You can add remoting. You can add asynchronous processing. You can make it. You can publish it out as a SOAP web service, a WebSocket endpoint, or a REST endpoint. Okay, so incredibly powerful, sort of compact thing to do at your backbone application layer. The bad. Overuse may introduce unnecessary layers. Yes, this is true. Okay, so if you don't need a facade, don't introduce one. Okay, if all you're doing is getting a database record out, don't create a facade for it. Just access your DIO directly, okay, and get access to your entity. And those are two words that we haven't explained yet. Hopefully, we'll get to explaining that. Okay. In other words, if you don't need an abstraction, don't create one. Okay, fairly obvious stuff. The ugly, well, there isn't much of one. It's really just the name of the pattern. It takes a little bit of thinking as to what it actually means and where you would apply it.
We don't need like the C with the tail in the facade. That's all. Next, the decorator. Oh, okay. So decorators add behavior to objects in runtime. So instead of inheritance, they have the ability to add functionality on the runtime to objects which are subject to be decorated. So they introduce huge amount of flexibility. And actually, we had war stories in our book with Alex, and I really enjoy. Actually, the whole war story idea was because of the decorator pattern. Because in my previous experience, I really messed up a project and couldn't really solve a simple problem which could be easily solved with a decorator. So, yeah, decorators can be really powerful, but you need to create some boilerplate code and have the interface and everything to just implement the classic implementation. However, in Java EE, it's again pretty straightforward. You just add the decorator annotation and you add the delegate object with the annotation. So this would decorate the product, actually the accessory object, and will execute the getPrice method when it's called. The way to enable the decorators is the XML declaration. So far, that's the first XML code we just showed and needed. And actually, the XML is also needed to decide on the order of the execution. So it's basically declares the order of the decoration. So you can have multiple decorators, and you can just add as much as functionality at the runtime without really changing the real implementation. The good, unlike inheritance, it's very, very easy to change the behavior, and you don't really change the original code. You just introduce a new decorator and just do the configuration, and it just works magically. The bad part, you may need to have some XML declaration, mostly for the order of the decorators. And the ugly, well, I'm not sure if it's really the ugly part, but yeah, overuse will introduce an execution flow. Again, very hard to understand. Well, yeah, might be, depending on the status of the project. But generally, they introduce quite powerful and flexible structures.
Okay, and the next one actually will finish off the Gang of 4 part. So good, we actually have some bonus material for you. There's some basic material that we were going to cover in this talk. Looks like we'll be able to get to that bonus material. So let's talk through observers. Observers, again, a little bit difficult to understand why it's needed in the first place. This, again, goes down to a basic fundamental requirement in object-oriented systems, namely passing a message, okay, from one object to the other, telling one object to do something as a result of, say, a state change on another object, okay? But the big difference here versus just simply invoking an object on a dependent method is that you care about decoupling in one way or the other. Perhaps you have an event for which you want to trigger multiple observers, okay, multiple endpoints that react to that particular event, or you simply want a bit of loose coupling because you want to change which observer actually gets triggered at runtime. Okay, so that is the real reason why you would, the original reason why you would need essentially the observer pattern. Now, the way you implement the observer pattern is sort of antithetical to the original goals of the observer, because the way you do this in Gang of 4 is literally you implement an interface, you have a bunch of objects that implement this interface, and then on the listener you actually have to register concrete implementations of each of those instances. Okay, so it's sort of a bit self-defeating if the goal is to create essentially loosely coupled systems. So how does Java EE solve this? Well, it's solved this in a much more loosely coupled fashion. So let's say we have this object here that is an observer. So it reacts to something else happening somewhere else in the system. So the way you express this is simply, create the method and give it its expected payload. What am I expecting? What am I acting upon? And simply add observable annotation. And what this says is observe an event, okay, that matches the payload of my method parameters. In this case, it's the string message, and I will act upon it. Okay, and unlike and the way this is actually invoked is not directly by instantiating or rather injecting an instance of hello world observer and invoking the trace hello worlds methods. After all, that defeats the purpose of two things. It's not very loosely coupled, and you couldn't have, for example, one-to-many relationships very easily. So the way this is actually triggered is by triggering an event, okay, that corresponds to the observer that you're listening on. So in this case, you would inject type event string, and then when you want that event to be triggered, when you want the observers to be triggered, you simply say event.fire and you give it the payload that you want. Okay, so in this case, again, you're getting loose coupling, and you can also have multiple observers listening on a particular on a single event. Okay. So what are okay? So this is just going a bit more into that, so you can observe not just primitives but your own custom objects, and that's how you would trigger them. The pros and cons, again, same thing with the rest of it. It's there's not, instead of having to write code to implement the observer pattern and do observer registration and deregistration and invocation, none of that actually happens for you in Java EE. It's just all managed by the container. You have a very simple API, just one annotation and an injection of an event object with a payload, and then you call fire. Very, very simple by comparison. The bad, yes, it can introduce, one second please, it can introduce difficulty in following the execution order. It's hard to determine, okay, if this event is fired, what is going to get triggered. Again, the IDE will help you do that, right? So, you know, NetBeans has a wizard to say, okay, when I'm firing this event, please tell me what observers would be triggered, you know, the corresponding. Not much that's ugly about this. You know, it's when you need it, this is an elegant solution to the problem. Yes, sir. Actually, he raised his hand first. Can somebody please relay that question? Okay. No, by default they are synchronous today. In CDI 2.0, they're introducing asynchronous observers. Okay, but that's in CDI 2.0, not today. Yes, sir.
So when you have the same type of payload, can you have different sets of observers for the same type?
Yes, by all means you can. So there's a couple of ways of doing that. Number one is that you can specify as many qualifiers that you would like. So in this, we don't have an example of a qualifier here. Oops, I'm clicking a bit too fast. 1 second, please. So you can most certainly have qualifiers, okay, the same, just like pretty much anything else that you saw, you can qualify this at observable. Okay, you can say, you know, observe a string message with the qualifier such and such. Okay, you could use the @named and a built-in qualifier, or you could create your own custom qualifier. And then what you would do is, when you are firing this, you have two options. You can statically provide the qualifiers right at the event injection point, or you can also specify them when you say event.fire. You can attach qualifiers there. So yes, there's yes, sir.
What happens if there's an exception in one of them? Does it stop there?
It does not. Yeah, execution continues, but you will get a nasty stack trace that you can later figure out what happened there. Yes, sir.
What is the practical use? Actually, what I'm going to ask is, what it is different when you thread monitor and a JMS observer?
Okay, so a bunch of things. So number one is look at the amount of code to do this. It's very, very trivial as compared to JMS. When you're doing a JMS invocation, there's a lot of moving pieces going on there. So you have transactions, persistence, all of those things you'll needing to deal with, right? In this case, none of that occurs. It's just simply a lightweight event. It's just an in-memory invocation, in-memory indirect invocation. As to what the use cases are, there's lots of use cases, right? So really anywhere where you would need an event, this is helpful. In particular, imagine that you have a significant set of events in your application that you need multiple endpoints to react on, and these are not important enough to warrant, you know, putting it in message-oriented middleware. Let's say perhaps a system warning, right, and anything of that nature. You know, this is a very, very helpful facility to do so. Okay, yes, sir.
CDI interceptor is kind of observer pattern.
CDI interceptor is not an observer pattern. CDI interceptor is an example of AOP of aspects. So that is not a gang of 4 pattern. In fact, it's not a pattern at all.
It's a mix of decorator and proxy.
You could say that, I guess. Okay. All right. Yes, sir.
So does the current transaction get suspended when you fire the event, or does it propagate?
Events do not have much to do with transactions whatsoever. The only place that they intersect is that you can have a observer that listens on the transaction. So you can get callbacks to say, my transaction got committed, got rolled back, so on. Other than that, there's no, if you need something transactional, yes, that's another use case for using JMS. Because in fact, JMS message will be transactional. This wouldn't be. This is just simply lightweight in-memory invocation. There's no transaction coordinator here. Okay. Anything else? Moving on. Excellent. Okay. So let's take stock of how much time we have left. I believe by my count we have 20 more minutes. Yes? Somebody confirm or deny that? About 15 more minutes, 20 more minutes? Okay, I think that's we're in good shape. So let's continue with the rest of the presentation, I think.
Yep.
So we're actually out of the realm of Gang of Four now. Okay, so what we are now talking about is design patterns that you ought to know about that for one reason or the other isn't in the Gang of Four book. Okay, but these are design patterns that you should know in enterprise applications, and in many cases, again, these design patterns are also built into the Java EE platform in one way or the other.
Yep. So let's move to model view controller, which is not a pattern, but a collection of patterns. So MVC is used widely in almost all UI frameworks. So believe it or not, if you did any kind of UI programming, at some point you used that. So the main motivation is to keep the data, the logic, and the UI code separate, so it will be easy to change one part without really breaking or introducing huge change to another part.
Also, more importantly, modularity, right?
Yeah. So, and luckily, JSF is a very clean and easy to write implementation of MVC, which is a part of Java EE. So, what's the model? The model is the part which represents the data and the related business logic. Usually the model in Java EE is the CDI bean. Next, it's the view. View is the visualization part of the data, which filters some fields and just visualize the data to the user. It also enables the user to interact with the data and also trigger the business logic. And the controller is the part which links the view with the model. So it directs the application flow and basically orchestrates the, everything in the MVC. So if you look at the MVC in Java EE, the model is annotated POJOs, which are annotated with named and request scope. The view is the facelets which are written in XHTML and, of course, with CSS. And the best part is the controller is something you don't need to care about. It's the faceless servlet, and you don't really need to write anything for the controller part.
In fact, that is the original intent of the MVC, MVC design pattern, the way it was implemented in Smalltalk. Smalltalk basically was the controller. You wouldn't never write a controller yourself. It's the exact same concept translated in exactly the same way in JSF.
Next, we move to the data part.
Mm-hmm. Okay, entity. This perhaps is the most important artifact that you'll have in your application. What is it? It's a representation of the nouns in your system, the important nouns. So these are what is it that you're attempting to model. So for example, in an e-commerce application, this would be catalog, product, customer, and so on. Okay, think of it as essentially, a rough way to think of it is the database tables that are stored in your relational database. These are your models. The entity object essentially is a naming of that concept. Okay, so an entity has, again, goes to the very core object-oriented programming. It's a particular, it's a specialization of object orientation. So in object orientation, an object has data and behavior. And in the end, it's supposed to emulate something that you're trying to model in software. And that's precisely the definition of an entity. Okay, so it's a thing that you're trying to emulate in the real world. It will have data roughly corresponding, again, to columns in your database tables, but it will also have business logic in it. How do you do this in Java EE? Well, it's quite simple because there is a very, very intuitive annotation called @entity in the JPA package. That is its exact intent, is to describe an entity object. Of course, in JPA, it really will allow you to map to a relational database or a non-relational database these days. Actually, you can do so. You can use JPA entities to map to non-relational databases. And yet again, this makes perfect sense because it would be highly unlikely that you have an entity that is simply goes away when you do an application restart. It's what would be the point of having it? So it's quite natural to think of entities as something that is persisted into the database. So a good place to put essentially the @entity annotation.
You don't have temporary entities?
Pardon?
I have temporary entities. Is that weird? I have entities that are temporary tables that go away. You don't do that?
No, I must say I haven't seen that too often.
They're lovely. You should use them.
Okay, all right. All right, so here's how an entity looks like. Okay, so here's a simple entity, contact. It has two attributes, first name and last name. It may also have behavior. There's no example of a behavior. Obviously, we're in sort of in an artificial mode of trying to fit in some logical bits of code on a slide deck. And in this case, it also has an ID that maps to the database. This is essentially something that goes into the database via JPA. Okay. The next related bit artifact or design pattern that is related to entities is called DAOs or data access objects. What is the purpose of this? The purpose of this is that data access code is often very atypical, okay, different from the rest of your application. Okay, so you have your presentation tier, you have your business logic, and then you have your data access code. The presentation tier code is naturally segmented in its own part because you're following the MVC pattern. The business logic, again, is naturally segmented in its own part because hopefully you're creating facades to encapsulate your business logic. However, there's no real good place to stick data access code. If you didn't have a layer to deal with this, you'd essentially pollute your business logic within your facade by not just writing business logic, but also doing data manipulation and data access concerns. So the purpose of the DAO is to give you that bit of abstraction, okay, to be able to decouple the business logic from the sort of the manual task of data access. Okay. Usually a DAO is going to be a singleton or more specifically an application scoped object. All right. For the most part, as you'll find out, you actually don't need real DAOs anymore in Java EE applications. The reason for this is because of JPA. JPA has an API called the Entity Manager, and if you really look at the Entity Manager, it's really nothing much more than a DAO. All right, it allows you perform CRUD operations on an entity, and it does it in such a high-level way that it makes the data access code virtually vanish. Okay, there's not much data access code to speak of anymore. However, still there may be complex cases where Entity Manager is simply not sufficient. Right? Maybe you're doing something a bit more complex than then simple Entity Manager CRUD operations. In which case, yes, you would actually create an object that you say is something DAO, let's say customer DAO, and then you would stick some code in there. So let's take a look at a brief example. This is a case where we're doing something very simple. We don't need a whole bunch of abstractions. We don't need an actual implementation of a DAO. All we're really doing is treating the Entity Manager API as the DAO. So we're injecting the Entity Manager. If we need to find an object, we simply find it by ID. If you need to persist something, it's em.persist, em.merge. as you can see, per operation, just a one-liner. You can't really abstract much more than that, and it's not necessary. In this case, your entity manager is effectively your DAO. Okay, DTOs are a bit of a interesting case. Again, in modern Java EE applications, you don't actually need a DTO per se. So before we get to that, let's get to what a DTO is. A DTO stands for a data transfer object. Okay, so quite naturally, where this comes into play is when you are crossing system boundaries. Okay, so a classical example would be a RESTful web service. Okay, so you're invoking a RESTful web service from one application to another application. Wow, what are we going to do with 15 minutes? Song and dance? Anyway, all right. Okay, so we have, let's say we have a remote RESTful web service. Okay, invoking a service from one endpoint to the other. And then what you have on each of these endpoints is Java binding. So you have the wire format, whatever that may be. Usually these days it would be JSON. But at the end of the day, if you're talking about a Java client and a Java server, both of those would have corresponding Java objects, okay, that you ultimately transfer on the wire to some other format. That artifact is a data transfer object. Okay, that is its purpose. Okay, that is its purpose in life, and hence it deserves its own pattern name. Now, again, in very simplistic, or rather in well-written, okay, Java EE applications, you actually don't need to necessarily create a separate artifact called something DTO, like a customer DTO. Because in many cases, you can simply perhaps treat your entity as your DAO. Okay, you can simply transfer the entity as is over the wire without any problems. No, use your entity as a DTO. Yes, correct. Right. So, but that won't always work. Okay, so in many cases, you may want an actual abstraction layer. Okay, so this would be, and a good example of this would be if you have a very complex domain object, okay, and you're only for a given web service, you're only publishing a small subset of your entire domain object. That's when you would actually create a specific DTO object. Generally speaking, the intersection between DTOs and Java EE is that Java EE allows you to declaratively do the serialization of a DTO. So it recognizes the purpose of the DTO object, and it allows for some annotations that you can place there to make that serialization. Okay, remember that's the whole point of creating a DTO in the first place happen. So here's a brief example. So let's revisit our entity class and assume that we're lucky enough so that we don't need to actually create a separate DTO object. We can simply use the entity as a DTO. But still, though, we don't want to publish out some of these objects, some of these values. So for example, a client probably doesn't care, what the ID or what the internal database ID of this implementation detail on my side is. Okay, they probably just care about first name and last name, and they will, when they send me the first name and last name, or it's my job to figure out how that maps to an entity. So the way you make this happen is simply, let's take JAX B as an example. Let's assume we're creating an XML serialization of this DTO. So the way this happens is you simply say XML root element, and that makes JAX B recognize this object as a DTO, essentially. In this case, the default access is method. Okay, we're changing that to be field. Fair enough. So basically, we're going to read through all of our fields and not look into the accessors, mutators, getters, and setters, and simply, push out whatever properties that I may have in this case. Well, in this case, I definitely do want the first name and last name to go out, and that's what's going to happen by default. I don't want the ID to be published, serialized. So you can simply say XML transient, okay, and that will stop the ID field from being serialized out, as a DTO. Okay. Finally, domain-driven design. Murat, you want to cover this one?
Let me have a look at it first. Actually, let me add one thing to the.
Okay.
Sure.
You said when you're describing DOs that you can just use the entity manager, but some of the older frameworks would encourage you to have the DO circle switch between, for example, a JDBC template implementation or a JP implementation or something like that. Is that no longer the case?
To be honest with you, no. Right. I don't see that happening. I mean, I've been developing Java EE now since Java EE 5. I have seen very little reason to use anything else other than JPA. So if JPA is all you're using, why introduce this other abstraction that you need to maintain from then on? So I'm not saying that what you're saying doesn't occur. Okay. All I'm saying is don't assume that it'll occur. Okay. Yes, sir.
I'm assuming it's occurring. My database isn't very good, so I want to hide all that behind a DTO. So when I change my database, make it better, the users of my DTO don't have to notice that I've changed anything. So I think that sort of goes to what you were describing before about reasons having a DTO. If you've got a good reason to do it, it's a perfect reasonable abstraction.
Sure. All right. Anything else?
And actually, if you're mixing
we have
up
a few more
your
questions.
entities and DTOs, you can also use the transient annotation. So some parts just are translated to XML, but doesn't written into the database, and vice versa. So the other question?
Use the transient keyword instead?
You cannot, no. JAXB does not recognize that.
Yeah, transient would be.
Has nothing to do with this. Yeah. That has to do with object serialization in terms of Java, native serialization. Okay.
So if you were using JSF and you were using a backing bean, would you then use the same object that you're using in JPA to persist as your backing bean?
In fact, by default, yes, you would. Yeah, because that minimizes code duplication in the end. Yeah, so why create unnecessary abstractions if you're never going to use them? It's just wasteful, right?
Or if you had a web service where you were handling XML,
It's
combining
Mhm.
the two aspects of it in one class.
Yes.
One of it is the XML handling, and the other part is persisting from the data.
Yeah, precisely. Yeah, you can do so. Yeah, that's exactly what's going on here. We're using this as probably for multiple purposes. You know, we're using it in the view layer of JSF. We're using it to persist the data, and we may be using it as a DTO as well. Yeah.
Now I have to convince the starchy developers that has to be separated.
Right, imagine the wasteful. I mean, this is called cargo cult programming. Have you heard the term? There's an interesting little graphic, but basically, using something without understanding its actual purpose, leading to sort of nonsensical usage. In this case, probably unnecessary artifacts that you don't need in your application.
Otherwise, you need some kind of a converter for impedance.
Exactly. Yet more code duplication, yet more baggage you sort of have to carry forward with your application. Yes, sir.
You said you can use the entities for JSF and the backend, like we can share the same entity. If you have a REST API that's using the same kind of entity, but you don't want to expose certain fields out of it, can we use the transient to hide those fields? Because
Yes, that was the point. Yeah, that was the point. I know we haven't done a great job of flushing out the entire. Remember, this is bonus material. But again, yes, yeah, that is really what we're trying to describe here.
is it possible to change the names of these fields? Like when you use
Yes.
XML documentation?
Yes, yeah, the simple way of doing so in JAXB. Yes, sir.
Are there any examples of non-SQL configuration or backend?
I didn't quite follow the
So you said
question.
with the entities, right, it can be relational and non-relational.
Yes. So look into Eclipse Link, NoSQL, or Hibernate OGM. Okay. All right. So let's give it a shot. Let's cover domain-driven design. I was being facetious because the reality is you can't cover domain-driven design in 5 minutes. Okay, it's its own talk. In fact, it's a talk that I gave last year in this very same room, ironically enough.
But it's on one slide now.
Right. So anyway, okay, so here's our best shot at explaining domain-driven design. Here's the explanation. Look it up. No, that was supposed to be a joke. Anyway, all right. Okay, so besides all of the things that we talked about, some of the things that we're talking about is actually somewhat old-fashioned. Okay, so principally we're talking about gang of 4 patterns and J2E core patterns. Okay, that's what the patterns that we described. By and large, that's where they're coming from. There's actually a whole different world called domain-driven design that takes all of these ideas, puts them together, and puts them in newer, more modern, cohesive fashion. Okay, so these are some of the design patterns that you should look into there. I've accidentally slipped and I actually mentioned those patterns in my facade when I was describing facade, and those would be things like application services. Okay, entities are entities in either world. Repositories are nothing much more than more fine-tuned, more sensible DIOs. There's slight differences between DIOs and repositories. Don't let anyone tell you that if you just rename DIO to repository, you're done. You're not. And there's also something called value objects, okay, in addition to entities. It's an extension of sort of the entity concept. There are, in factory is another recognized design pattern in domain-driven design. And if there's a few others that I won't talk about. Principally, we want to put this here so that you should look it up. All right? So there's some interesting patterns there, and again, they map quite nicely to Java EE because Java EE has those same concepts in them, okay, including things like value object and most certainly factory and the like.
So that part was more like a homework. So you should go home and study and.
Okay.
Back to the entities as DTOs. I know you're saying that that transient that needs some control, but if you're using that object, say you have a business that's saying, yeah, I don't want the ID, but another part of the business does want that ID, but how do you control that?
You can. That would be a legitimate reason to create 2 separate DTOs. Okay. Yes, sir.
So over the years, I've seen a lot of discussions around entities and having business logic in them. Some camps want entities with all the business logic outside of the data layer.
I'm in that camp.
And some of them want, they seem as domain objects and they want them to be big and rich and have a lot of functionality. What's your opinion on that?
My opinion on that is you should use what works best for you. Okay, for me, domain-driven design works best for me. I like to have the business logic very close to the data itself. Okay, so I want the data and the business logic that operates on it in the same place. I find it more maintainable and a more logical place to look at those objects, and it makes it easier for me to communicate with my developers when I'm talking about the domain model. I don't have to say, oh, customer entity, and look in this other little service that has this business logic in it. Okay, I can simply say, go look it up in the customer entity. It's in there. If you don't like that way for some reason, one reason would be that this way is harder. Okay, you have to do a lot more analysis upfront and continual analysis to make this happen. To really, because at the end of the day, this is what object orientation is about, right? And it's not easy. Object orientation doesn't come for free. It implies analysis and thought. If you don't want to do that, simple way is my entity is just a dumb representation of a row in my database table. I'll just stick all of my business logic in the application layer. I don't have to do any analysis. Who cares about all that stuff? That's yet another way of thinking about it.
That's what I accept.
All right.
No, I do.
Okay.
I wanted to just, as an add-on to what that gentleman just said, I've heard one of my colleagues mention that the differences between the CDI and JPA life cycles kind of creates problems for creating these rich entities. I was curious how you kind of work with that.
Yes. So you need to be aware of those problems, but they don't impede you from using entities in the presentation tier. So you need to be more aware of using things like producers in a proper way. using scoping in a more clever way, and you can get around those problems. Those are not show-stopping problems. They are hiccups, but there's unfortunately no elegant solution to resolving those life cycle issues. You just have to be aware what's going on and simply add a producer, to be honest with you. Yeah, okay. Yes, sir.
If you have to use the entity just as a backing period, then all your data operations, transactions, everything would be a separate method in the same entity.
That, I think, is carrying reuse a bit too far. I do see value in MVC and separating. What you would wind up doing there is essentially mixing the presentation tier with the transaction tier. I'm all for getting rid of unnecessary cargo track artifacts, but I think that just goes a bit too far. Okay. Any other questions?
So who do you think will win a book?
I think that gentleman over there, right? Yeah.
Anyone else?
Okay.